Hello everybody, I will start my today's another live coding session. Today I solve this question, Permutations II. Given a collection of numbers, nums, that might contain duplicates, return all possible unique permutations in any order. So I'm given a collection of numbers, and this might contain duplicate, and I will return all possible unique permutations in any order. Okay, good. So let me first confirm my understanding. So in this question, as the interface, I'm given an array of numbers. So I'm given this, and I will return all possible unique permutations in any order. So I should return to the array of numbers. Yeah. Internally, the internal array is the permutation, and the outer array is the list of such permutations. Okay. And as it's written, these numbers may have duplicate like this. So in this case, I should return something like this. Yep. Okay. So I shouldn't distinguish 1 and 1. So I shouldn't include 1 and 1, 1, 1, 2 twice. I think that's the most important thing I have to take care when I think of the duplicates. Yeah. And as the edge case, I can say if the given array is empty, then I should return an empty array because I don't have any permutations. Okay. So let me think of the algorithm. I think that the brute force approach is create every possible permutation, let's say with backtracking, then put each of them into the set, return the set. And I will do deduplication. Deduplication is the key because, as I said, I have 1 and 1 duplicated, for example. So just a direct backtracking doesn't work. So choose number 1 by 1. Yeah. And try every possible case recursively later. So that's the backtracking approach. But this doesn't work. No. I mean, I have to do deduplication. Yep. So this is a possible idea. And I don't know, the time complexity should be. So let me clarify a little bit more. So when I think of this, I'm building the permutation and I do the backtracking. So I chosen nums array, which should be to which numbers are appended or from which numbers are removed after the recursion. And also I should need the return array. Yeah. So for this build method, I guess the start index. So in the base case, I create the array from chosen nums and add it to the returned set. Yeah, or something like that. And otherwise, from here, I choose the number which hasn't been chosen in chosen nums. Then I do the recursion. Yep. So this works, but let me, recommend, or I should say, introduce another approach. I do the backtracking here, but instead I do the creates a counter, like num to count. So, for example, in this case, the counter should look like this. And every time I call the recursive function, I chose the number and count. Yeah. So in this way, I don't have to think of the duplication because no, I have to think of it. Let's say I have 1 twice and then maybe what I can do is if I choose 1 twice here, then I shouldn't choose 1 again, because if I choose 1 again, it is the same as choosing 1 3 times. Yeah. So that's the kind of approach I can take here. Maybe the previous number can be found in the last element in the chosen nums. But I think this isn't so clear, or I should say, not so clean. So I will go with algorithm number 1. Do the backtracking and then create the set and, deduplication with the set. Okay. Now let me start the implementation. Maybe I have to convert it to set. Okay. So in the build method, as the base case, if I've chosen all the numbers given, this is the base case. So I create the permutation. So I will create a tuple because I have to push this into the set, and each element in the set has to be immutable in Python. So I convert this to tuple. Then I added this. Okay, so this is a base case. Otherwise, I will choose some number which hasn't been chosen yet. So maybe I should keep track of the remaining numbers here. Okay. And here, for each remaining number, I can choose I can choose it as long as there is. So I choose this number, so self dot chosen nums. then decrement the count, and I have to make sure that this if the number of this remaining number is 0, I have to remove this key. Otherwise, in line 56, I have to take a look at the number which has been removed. Yeah, in that case, this count should become -1. Okay, so now I call the recursive function. Then after I come back, I roll back the changes I made. Like this. Okay, this is it. So let me quickly check. So in the build method, this is the base case in line 51. And in line 56, for each remaining numbers, I appended the chosen numbers list and also decrement the count and call the recursive function. And after coming back, I roll back the changes. Good. Okay, so let me dry run. I will go with the basic. Yeah. Okay. I will go with the basic case. So let's say this edge case. In this case, it is expected that I return the empty array. So self.nums is empty array, self.ret is empty set, self.chosen_nums is empty list, and random count is nothing. And self.build 0. So start index is 0, and in line 56, this is equal. They are equal, so this is a base case. So I create the permutation. So this is an empty tuple. An empty tuple is appended to par. Then I return. Oh, this isn't as expected. Actually, as the constraint, num ranks is more than 1 or equal. It can be 0. Just let me add this as the base case. No, edge case, I will return. Okay, now I pass this case. So let me check with only this one. So in this case, it is expected that this returns only 1, 1. So self.nums is 1, 1. Self. Is return is empty set. Chosen nums is empty list. Remaining num count is now 1, 2. Yep. So I call the build method with start index 0. And this is the base case. I go to line 71. And I take a look at number 1 first. Then I append it to this. Yep. Then random count this is decremented to 1. Then random count is not 0, so I go to line 76 and I call the recursive function with start index plus 1. So now it is called with 1. So here, when it is 1, then as the base case, I go to line 71 and num is only 1, 1. So again, I append this to 1 here. And then, because self.random count num is equal to 0, I delete this key. Yep. And I call the recursive function. And then line 66, chosen nums length is equal to, start index is 2, which is equal to length of self.nums, which is 2. So I create the permutation 1, 1, and append it to the read. Yep, this is good. And I return in line 69. And I come back to line 76. And what I do is, so I go to 77 and I chose nums pop. This one is popped out. Then real number count num plus equal to 1. So now it becomes the 1, 1. Yep. Then this is the end. So I come back to another parent recursive function. So here it was 0. So I came back to here and then write 76. 77. I pop out this one. And then this becomes 2. Yep. And I go out of the for loop and I come back to line 63 and return the rest of read, which is this one. I mean, this is converted to rest, so this is exactly what I expected. So I passed this test case. Okay, good. So the thing I couldn't cover is something like this. Like I have 2 choices to choose, 1 or 2. Yeah, I didn't cover it, but yeah. But still, I'm pretty confident in my code because I could cover the lines to execute my code. I see. So here, I can't mutate the random count hash map inside of the for loop. So I create the list from this one. Good, accepted. Okay. So from here, I will do the complexity analysis. So for time complexity, firstly, let me think how many times this build method is called. So for the recursive function, let's say there are n element in the given given nums list. So the argument start index can be n. No. Wait. Sorry. So let's just say firstly, there are n choices. There are n choices. And I choose some number. Let's say I have 3 numbers in the given array. In that case, I have 3 choices. Yeah. Then next, build 2. Let's just say I have 2 choices. So for each number I chose, I call this build 2. Then here I have only 1 choice because remaining number is only 1. Yep, like this. Okay. So this happens, the same thing happens here. So in total, let's just say, so firstly, when start index 0, this is called only 1 time, and I have n choices for the next number. And when build is called with index 1, there are n times build is called with argument 1. And for each, I have n minus 1 choices. Then next, build 2. Because I've chosen 2 numbers and there are n times, oh, it's been 20 minutes. N minus 1 choices so far. And from here, I have n minus 2 choices. So, wait a minute. And for the first one, I have only one. Build 0 is called only one time. Yep. For build 1, this is called n times. And for each, I have n minus 1 choices. Build 2, this is called n times n minus 1 choices. I mean, n times n minus 1 times. Because this is exactly which number I chose so far. There are n times n minus 1 combination. And for each, I have n minus 2 choices. Then the same thing happens like this. So